Picture a room full of screens where the work looks deceptively simple. A sentence appears, someone highlights a phrase, a photo loads, someone draws a box around a tool in the worker's hand. Two model replies show up side by side. Someone clicks the one that feels more helpful and less risky. Repeat this across time zones, languages, and cultures millions of times a day. Now imagine those clicks and boxes flowing into a pipeline that trains the next generation of models, the ones that summarize your documents, answer your questions, and write the code that runs your business. We talk about compute like it's the fuel of artificial intelligence. But there is another input with its own price, speed limits, and failure modes: human judgment. In the next 20 minutes, we will step behind the interface into the factory of data. You will see why labeling and reinforcement learning from human feedback are not side quests but core levers, how costs and incentives shape the quality of intelligence you get, and what decisions separate teams that ship durable models from those that quietly lose trust. If you care about the real economics of AI, follow the pipeline. It starts with people. Let's set the stage in plain language. A general-purpose model learns its scaffolding from mountains of text and images swept from the open web and licensed sources. That pre-training teaches grammar, facts, patterns, and style. But pre-training alone produces an agent that is smart in aggregate and socially clumsy in practice. It can be right and still feel wrong for your product. That is where curation and feedback enter. Before you fine-tune a model, you decide what goes in and what stays out. You deduplicate obvious repeats. You filter spam and low-signal content. You include documents that match your domain and your tone. Then you teach the model how to behave with instructions and examples. You ask people to rate outputs, pick better alternatives, correct reasoning, and reject unsafe suggestions. Those judgments are not decoration. They become the loss functions and reward signals that steer the model's behavior. Why this matters today is simple. Generative systems have moved from research to customer-facing features. A slip in quality is now a brand problem, a support cost, a legal risk. The throughput and fidelity of your human-in-the-loop pipeline translate directly into margin and trust. If your data factory is slow, your product cadence lags. If your label quality wobbles, your model drifts. If your guidelines are vague, you end up paying for noise. Under the hood, 3 engines drive this factory: labeling for supervision, preference collection for alignment, and curation for everything that surrounds them. Labeling looks like classification, extraction, and annotation. A rater marks whether an answer is factual, grounded, and in policy. An editor rewrites a response to follow style. A specialist tags entities in medical notes, or steps in a piece of code, or bounding boxes in industrial imagery. Good programs mix generalists with experts and seed every batch with known gold items to catch drift and fraud. They define clear rubrics up front, because vague rubrics create disagreement that no amount of majority voting can fix. Preference collection looks different. Here, the same prompt yields 2 or more candidate outputs. A human picks the one that best matches your target behavior. Those choices train a reward model, an estimator of what we like, and a second step then tunes the base model to maximize that reward while staying inside safety limits. That second step once used reinforcement learning algorithms, hence reinforcement learning from human feedback. But direct methods now exist that match or exceed it. Whether you use classic RLHF, direct preference optimization, or a cousin, the heart of the loop is the same. You convert messy human preferences into a metric a model can climb. Curation is the frame around the canvas. Before anything reaches a labeler, you triage and sample. You decide which slices of the web you trust, which licenses you honor, which languages and domains you need, and how you handle personal data. After labeling, you clean and audit. You look for annotation artifacts, like words that appear only near positives, and you search for annotator shortcuts, like patterns that game the rubric without improving quality. You fight duplication by hashing and by model-based near-duplicate detection, because echoing the same paragraph across datasets makes the model falsely confident about that paragraph and dull elsewhere. You decontaminate evaluations so you don't accidentally test on what you trained. When you add retrieval, letting the model read your knowledge base at runtime, you build a second data pipe. Documents must be chunked and indexed cleanly, and your labels must capture whether the model properly used those sources. The physics of this factory are not glamorous, but they decide how much value your compute unlocks. The turning points in this story all revolve around trade-offs. The first was the decision to industrialize human feedback rather than treat it as an afterthought. Early systems tried to ride pre-training quality as far as it would go. Teams then discovered that small amounts of well-structured human guidance, how to follow instructions, how to decline harmful requests, how to weigh clarity against verbosity, moved the needle more than yet another terabyte of noisy text. Companies built internal teams, and a marketplace of vendors emerged to supply raters at scale across time zones. Choices here mattered. Some went for speed and low price per task, flooding the pipeline with quick judgments. Others paid for depth, hired domain experts, and accepted slower throughput. The second hinge was the shift from single-label supervision to pairwise preference learning. Instead of pretending there was one right answer, teams embraced better-than comparisons that map more naturally to human judgment. That change unlocked smoother alignment. Reward models could learn subtle preferences about tone, helpfulness, and safety that hard labels struggled to capture. A third hinge was where to put expertise. Many programs tried to train the base model to be a jack-of-all-trades and then bolt on domain behavior later. Others inverted the order. Keep the base model reasonably general, but invest heavily in domain-specific instruction tuning with expert-written examples and rigorous review. The latter often wins in business settings because it concentrates scarce human hours where they buy the most. A fourth hinge is the rise of AI feedback. Once you have a reasonably aligned model, you can use it to propose labels, critique its own drafts, or generate preferences that humans then spot-check. That can cut cost and extend coverage, but it carries a trap. A system can amplify its own biases and blind spots if you rely on it unchecked. The cure is humility and measurement. Sample the tail, not just the mean. Keep humans on hard cases and new domains. Maintain challenge sets that reflect the real failures your users see, not only academic benchmarks. The final hinge is worker well-being. Some labeling involves unpleasant content. The teams that last design guardrails, rotate tasks, provide mental health resources, and give labelers the right to skip. Not because it looks good in a slide, but because exhausted people produce noisy data and drift away, leaving you to relearn the same lessons with new staff. These choices spill into economics in ways you can model. Start with throughput. A modern training run can consume millions of preference pairs or instruction examples. If your pipeline produces 10,000 high-quality labels a day and you need 1 million for your next milestone, you are looking at months unless you parallelize or increase quality-adjusted speed. Now, layer in quality. A label is not a label. Its value depends on clarity of rubric, worker expertise, and agreement. Disagreement is not inherently bad when the task is subjective. It is a signal that your rubric is underspecified or your sampling spans cultures and context your product will face. Instead of forcing consensus, you can model rater identity as part of the learning process. So the system learns that Group A prefers concise replies while Group B prefers more background. Next, consider cost per usable label. The invoice price is only one line. You also pay to write and iterate guidelines, to build tooling that reduces confusion, to run audits, and to relabel edge cases after model updates. Teams that ignore these hidden costs see their spend rise with little movement in quality. Teams that invest in good scaffolding see cost per unit of real improvement fall. Unit economics of RLHF have their own shape. The first step, training a reward model, saturates after a point. Once it captures your core preferences, feeding it more of the same produces diminishing returns. The second step, tuning the policy model to that reward, can erode factuality or diversity if you push too hard, a phenomenon you feel as blandness and safe but useless replies. To counter that, teams mix objectives. Helpfulness, honesty, and harmlessness sit alongside faithfulness to sources and factual grounding. They also constrain optimization with techniques that penalize divergence from the base model's knowledge. In practice, the expensive part is not a single run but the iteration loop. Collect preferences on new failure modes, retrain the reward model, retune the policy, re-evaluate. If your loop runs slowly, you ship fixes slowly. If your loop runs fast but without guardrails, you ship regressions. The steady winners build a cadence where human ops and model ops move as one. The modern echoes of these mechanics show up in surprising places. Customer support bots live or die by the quality of their escalation policy and the labels that train it. A crisp rule like handoff when confidence drops below X or when the question includes billing or cancellation can save dollars and goodwill. Code assistants depend on datasets where functions are small, testable, and licensed. Here, curation is most of the work. You prune broken examples and emphasize patterns that match the developer experience you want to create. Creative tools lean on human preference for style, composition, and restraint, not only on pixel-level accuracy. A label like "this image evokes the brief better" can steer a model more effectively than a dozen technical tags. Safety systems rely on red teaming, deliberate probing for failures, and the labels that mark not just bad, but why. In multilingual settings, the pipeline must respect dialects and cultural context rather than treating them as noise. When teams ignore these realities, they experience the same failure. Expensive models that look excellent on proxy benchmarks and awkward in the wild. There are real limits and honest critiques to this approach. The phrase "human cost" is not just a metaphor for money. People who moderate harmful content or evaluate disturbing edge cases can be exposed to material that most of us prefer not to see. Responsible programs mitigate that with filters, rotations, and support, and by aiming models away from those domains when possible. Another limit is bias. Human preferences are not uniform. They vary by culture, language, profession, and lived experience. A model aligned to one group's sensibilities may inadvertently alienate another. You can soften this by supporting user-selectable styles and by building evaluation sets that reflect your real audience. There is also the risk of overfitting to the rubric. When raters are paid per task and time is tight, they will learn to pass the test rather than to think deeply. The fix is better tools that reduce ambiguity and audits that reward care. A final nuance is legal and ethical. The inputs to pre-training and instruction must respect licenses and privacy. The best practice is moving toward clearer data provenance, enterprise opt-outs where users control their content, and paid licensing for high-value corpora. Those steps raise near-term cost but lower long-term risk. From the ground truth of these constraints, a practical playbook emerges. Begin by defining good in the language of your product. State what a helpful, honest, and safe answer looks like for your domain, with concrete examples that you keep updating. Treat your labelers as users. Give them interfaces that surface context, allow uncertainty, and capture free text rationale that concede better rubrics. Use active learning to focus human time on the most informative examples, uncertain cases, novel prompts, and hard negatives. Blend generalists with specialists and pay for expertise where mistakes are expensive. Seed every batch with known checks to track drift and catch shortcuts. When you add AI assistance in labeling, do it openly and measure it. let models propose, humans dispose. Track quality by cohort and by rater identity, not only in aggregate. In preference learning, diversify your pairs. Include close calls that teach nuance, not only obvious wins. Keep your evaluation sets clean and fresh. Build a small council that decides when to ship a tuned model and require that it beats the current one on user-relevant metrics, not just on average scores. Above all, line up incentives. Bad incentives leak into labels fast. Zoom out, and the strategic lesson is straightforward. Intelligence at scale is not just a function of silicon. It is a function of organized human judgment. The teams that win treat their data pipelines like factories with real inputs, outputs, and quality control. They know the hourly rate for a rater and the cost of a labeling sprint, but they also know their cost per unit of improvement and their time to close a known failure mode. They invest in ethics because it reduces noise and turnover. They build relationships with vendors that go beyond purchase orders to shared standards and playbooks. They experiment with AI-generated feedback, but they never let the system grade its own homework without a human spot check. They don't worship a single metric. They pick a portfolio of metrics that reflect their product's reality, and they accept that alignment is not a one-time project, but a standing function, like security or reliability. That posture is not romantic, it's operational. It acknowledges that the most precious resource in your AI program might be attention. Yours, your labelers, and your users. We can end where we began, with the simple act of a person choosing between two answers. That click contains a value judgment about clarity, usefulness, and risk. Multiplied by thousands, it becomes a gradient that steers a model's behavior. Multiplied by millions, it becomes a strategy. Compute will always matter. But if you want models that your customers trust, the edge lies in the care you take with data and the people who shape it. If this episode helped you see the hidden factory behind AI and the levers you can actually pull, stay with us. On Incentive Atlas, we turn complex money and technology systems into decisions you can act on. Tell me in the comments where your bottleneck is today: sourcing, labeling, preference learning, or governance, and which one we should unpack next to help you ship with confidence.